Dear students, I am Nilanjana Sanyal. Welcome you all to my channel NS Online Math Classes. Our today's topic is rewriting logarithms in terms of other given logarithmic expressions, and we will be given 3 logarithmic expressions and they will be named as P, Q and R. Okay. In our previous session also we had written the given expressions in terms of a single log term or a single logarithm, which was named as U. In our today's session we are having 3 logarithmic expressions named as P, Q and R. We have to rewrite the given logarithms in terms of P, Q and R. The final answer should be containing P, Q or R or a combination of these 3 variables. And the only other thing that may be included in the final answer is a constant term, is a pure integer. Okay. And as before, we will be having 4 questions in this session. We will be solving 4 questions in this session. And the third and the fourth questions will be really challenging ones. So I'll definitely be asking you to stay tuned till the end so that you know the process completely. And without any further delay, let us start with our today's session. First of all, let us know what do these variables refer to. So write the following logarithms in terms of P, Q and R. If P is equal to log of 2, that means the base is 10. Q is equal to log of 3 and R is equal to log of 7. Question number 1. Log of 6. We have to write log of 6 in terms of P, Q and R. So, how can 6 be written? Always you have to think that how to write the given argument if the base is the same, of course. Over here the base is 10. If the base is different, the first thing that you have to do is make the base the same. We have not learned the change of base rule, so we will be taking the same base every time for all the 4 questions that we will be doing in our today's session. But in case you have a different base, first of all, change the base of the given logarithm to the base of the other logarithms. Okay, that should be your first step, and then you can use the method that we will be applying in our today's session. Okay. So, always we have to think how to express the given argument of the given logarithm in terms of the given other logarithms. So, we are having the arguments of the given other logarithms as 2, 3 and 7, and 6 can be written as 2 times 3. So we will be writing log of 6 as log of 2 times 3. And then we expand, it becomes log of 2 plus log of 3, which is equal to log of 2 is P and log of 3 is Q. So it will be P plus Q. This is the final answer. Coming to question number 2. Log of 108. Again we have to think how to write this number 108 in terms of 2, 3 and 7. We can use all of them, or we may use only one, or we may use 2 of them. We may use their powers, but we have to come to this number 108. Now 108, the first thing that is coming to my mind is it is 9 times 12. Because that is what I had learnt in my childhood years when I was learning the multiplication tables. 108 is equal to 9 times 12. And 9 is 3 squared, so 9 can be written in terms of log of 3. But what about 12? 12 can be written as 4 times 3. And that 3 can be combined with the 9, so it will be 9 times 3, that is 27, and the 4. And 27 is 3 to the power of 3, so it can be expressed in terms of this log of 3. And 4 can be expressed in terms of this log of 2. So therefore we write log of 108 as log of 27 times 4. And we expand using the product rule, so it is log of 27 plus log of 4. And 27 is 3 to the power of 3, 4 is 2 to the power of 2. And the powers will be coming down to the coefficient place. It is 3 times log of 3 plus 2 times log of 2. Log of 3 is q and log of 2 is p. So it is 3q plus 2p. 3q plus 2p. Okay. Coming to question number 3. Log of 35 divided by 2. Now we can use the quotient rule to write this, expand this, and we will be having log of 35 minus log of 2. And we have log of 2. In place of log of 2, we will be writing p. But what about log of 35? 35 is 5 times 7. We have log of 7, but we don't have log of 5. So what can we do? We cannot keep log of 5 in our final answer. But if we can come to log of 10, because the base is 10, we know log of 10 will be equal to 1. But how can we make log of 5 equal to log of 10? That is not possible until and unless we do something. So what should we be doing? We can multiply both the numerator and the denominator by 2, so that instead of 5 we get a 10. Because log of 5 cannot be written. We have to get a 10. How to get a 10 from 5? Of course, we have to multiply by 2. And we cannot multiply only the numerator by 2. We have to multiply the denominator as well. Because otherwise the value of the argument will be changing. Instead of 35 over 2, we can write 70 over 4. They are the same. But instead of 35 over 2, we cannot write 70 over 2. Okay? So, we write log of 2 times 5 times 7 over 2 times 2. And we combine these two. 2 times 5 will be 10 and this is 7. So, it is log of 10 times 7 over 4. And now we can expand using the quotient rule. It will be log of 10 times 7 minus log of 4 can be written as log of 2 to the power of 2, because we have to come to log of 2. And now we expand this. It will be log of 10 plus log of 7 minus 2 comes down. It is minus 2 times log of 2. And log of 10 to the base 10, of course, is equal to 1. Plus log of 7 is r, and this is minus 2p. We can have a pure integer. I have said that before. In addition to these three variables p, q and r, the only other thing that is allowed in our final answer is a pure integer. So the final answer will be 1 plus r minus 2p. Clear? Coming to question number 4. Log of 75. All the log terms are having the base 10. As I have said before, the base is taken to be 10 because we have not learned the change of base rule till now. If you have some other base, first of all, change the base to base 10 because these are in base 10. First of all, you have to change the base to base 10 for the given logarithm, which has to be rewritten, and then you apply the same method that we are applying in this session. Okay, that should be the additional step, and that should be the first step, the change of base if required. Okay, but over here the base is the same, and what can we write? How can we express this 75? This is 3 times 25. And we have log of 3, but we do not have log of 25. 25 is 5 square, so we do not have log of 5. The same difficulty that we had faced in this question. So what do? If we multiply by 2, doesn't help. 25 times 2 is 50. Doesn't help. But 25 can be written as 100 over 4. Because the base is 10, that's why we can think of 100, taking the number 100. Okay, because it is 10 squared and the base is 10. So 25, we will be writing 25 as 100 over 4. It is 3 times 100 over 4. In place of 3 times 25, we are writing 3 times 100 over 4. And we expand, it is log of 3 times 100 minus log of 4. And 4 is 2 to the power of 2 and 100 is 10 to the power of 2. And we expand this part, it is log of 3 plus log of 10 to the power of 2 minus log of 2 to the power of 2. And these two 2's come down in the coefficient place. Log of 3 is equal to q, and this is 2 times log of 10. Log of 10 is 1, so it will be 2 times 1, which will be equal to 2. So it is q plus 2, and this 2 comes down, it will be minus 2 times log of 2, which is p. So it is minus 2p. The final answer is q plus 2 minus 2p. Okay. So this is how, even though we are not given log of 5, if you face such a situation, you have to see what is the base. And you have to express the number that is creating the problem. You have to multiply or you have to divide, whatever you do. You have to come to some part of the base so that you have the final answer given in the terms of the variables given, and at most the only thing that can be added or subtracted is a pure integer. Okay. So students, this brings us to the end of this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.